You know, it feels like we're all just swimming in information these days. Articles, emails, research papers. It's just a constant flow. And trying to figure out what's truly important, what the core insights are, well, that can be a huge challenge.
Absolutely. And that's precisely why we do these deep dives. We take a stack of source material like the fantastic notes a listener shared with us for this one, and we try to cut through all that noise.
Get right to the good stuff.
Exactly. We aim to get you straight to the most important nuggets, the surprising facts, and maybe those satisfying aha moments.
And today, it's a great story we've got. We're tackling a truly complex real-world problem, a company trying to manage software deployment across a massive distributed system.
And this is years ago, right? Well before AI was the buzzword it is today.
Yeah, they relied instead on, well, ingenious layered automation.
So our source material is this detailed account from someone who was right there, living and breathing this problem. They walked us through the whole journey of building this sophisticated system.
Specifically designed to automate database upgrades across hundreds of remote sites.
Hundreds. It's quite the scale.
So our mission today is pretty clear. We're going to unpack this whole saga. We'll look at the initial pain points, understand the step-by-step solutions they developed painstakingly, and see the surprising impact of the final system they created.
It really is a masterclass in tackling complexity, kind of one layer at a time.
Okay, so let's jump right in. The beginning of the story. The core challenge they faced sounds, well, incredibly painful.
Managing database upgrades across hundreds of geographically scattered sites.
Hundreds of sites. Just, picture that logistics challenge alone. Not centralized, but spread out everywhere.
And at each of these sites, it wasn't just one database they had to worry about. No, there was a minimum of 3 SQL Server databases running locally. And the expectation was that this number would only grow, adding more complexity down the line.
Okay, so the fundamental problem was getting database updates, schema changes, new features, bug fixes rolled out consistently and reliably to all of these instances.
And the way they started, completely manual. Developers were tasked with creating a single Delta script for each upgrade.
A Delta script.
Yes.
Just to clarify for anyone less familiar, that's basically the script that contains only the changes needed to get a database from version A to version B, right?
Correct. It's the difference, the delta, between the before state and the after state, all captured in SQL commands. And creating that manually, well, the notes describe it as really time-consuming for the developers.
And risky, I bet.
Incredibly risky. It's so easy to miss something in a complex database structure when you're doing it by hand, especially across multiple databases that might have, slight variations.
Oh, I've definitely had moments wrestling with manual updates and just sort of holding my breath, hoping I didn't miss a step. So, yeah, I can feel the pain there.
You can imagine. And once that script, hopefully complete and correct, was finally created, it then had to be sent out to each site.
And who was running these critical database scripts at the remote sites? Was it IT professionals?
No. And this was a huge bottleneck, a major source of error, actually. The scripts were run by non-IT staff at each local site.
Non-IT staff? Oh, wow.
Yeah, people whose main job wasn't database administration or complex technical troubleshooting.
That adds a whole layer of potential difficulty. If something failed, which, let's be honest, complex database scripts are prone to do if the environment isn't exactly right.
Exactly. It was incredibly difficult for that non-IT staff member to figure out what went wrong, which led, predictably, to a flood of support calls. And sometimes, even worse, requiring expensive physical visits by support staff just to fix a single failed upgrade at one site.
So the manual process was just a nightmare. Developer time, risk, support burden. The writing was clearly on the wall. They needed automation, significant automation.
Right. So where do you even begin automating a problem this big, this complex? They started, wisely I think, by targeting that initial bottleneck. This was freeing up developer time by automating the creation of that Delta script itself.
Smart. Tackle the most time-consuming, error-prone part first. Take the developers out of that tedious manual differencing process.
So they met with their database administrator, the DBA, to discuss options. And it turned out there were commercial products available, even back then, specifically designed for this task.
So they didn't have to build this piece themselves? That must have been a relief.
No, not this first part, thankfully. The notes say they trialed and eventually purchased licenses for 2 competing products. And the way these products worked felt quite advanced at the time.
How did that work?
Well, you needed 2 databases set up. A baseline SQL database, which mirrored the current state of databases out of the live sites, and a new database representing the desired state after the upgrade.
Okay, so you build your target database, keep a copy of the old one, and then you feed them both into the tool.
Precisely. You pointed the product at these two databases, and it would analyze the differences and just generate the necessary Delta SQL script automatically.
That does sound pretty revolutionary, especially compared to doing it by hand. The notes even captured that feeling, saying it seemed like AI, or at the very least pure magic.
Yeah, given the alternative, it absolutely must have felt that way. These tools were also quite flexible. Apparently, you could configure them to exclude specific parts of the schema or generate separate data scripts just for configuration data, things like that.
Okay, so they solved the Delta script creation. Developer time saved. Huge win. But this commercial tool still required those two source databases, the before and after versions, to be ready and accurate.
Right.
And they still had the massive problem of actually running the script on hundreds of remote sites.
Which leads us nicely to the next logical step in their automation journey. The thinking evolved. Instead of manually creating and maintaining those baseline and new databases for the commercial tool, why not manage the database schema and data definitions as scripts themselves, stored in version control?
Treat the database structure like code, essentially. That's pretty common practice now, but maybe less so then.
Becoming more common, yeah. But the implementation was key here. The new goal was to automatically build those baseline and new databases directly from these version-controlled scripts whenever they needed them.
Making sure they were always an accurate reflection of the script definition.
Exactly.
Okay, so the challenge shifts from how do we create the Delta script to how do we reliably build a database from just a collection of scripts.
And this is where the DBA had a really insightful suggestion, according to the notes.
What was that?
What was truly needed wasn't some super complex database builder application. What was needed was something reliable to just run a series of SQL scripts in a defined order.
Just run the scripts. That sounds almost too simple for building an entire database from scratch.
And that simplicity was the genius of it.
Yeah.
The core concept they landed on was based purely on execution success. If every single script in a sequence ran without error, that sequence was deemed a success. If any script failed, the whole sequence was a failure. This simple binary outcome was absolutely crucial for reliable automation down the line. It gives you a really clear signal.
Ah, I see. It's not about complex parsing or intelligence within the runner itself. It's just about creating a clear, unambiguous outcome that other automated steps can depend on. Did it work? Yes or no? Simple.
Exactly that. And to manage the order of these scripts, because order obviously matters in databases.
Right, you need to create tables before you add data or before you create stored procedures that use those tables.
Precisely. So they structured them logically into folders, all your table creation scripts here, all your index scripts there, stored procedures somewhere else, and so on.
Makes sense.
And the order for processing those folders was defined in a simple text file they called the folder list. This file just told the application, run everything in this folder first, then everything in this folder next, and so on.
Okay, but how did this script running application handle failures? If one script didn't run correctly, did it just stop?
No, it had some built-in resilience. It would
Yeah.
track which scripts succeeded. If one failed, it didn't stop immediately. It would actually continue processing other scripts in that folder and then subsequent folders according to the folder list.
Oh, interesting.
Then, after attempting everything, it would go back and retry any failed scripts. You could configure how many times it would retry.
Ah, giving transient issues like a network blip or something a chance to clear up.
Exactly. If, after all the retries, script still hadn't run successfully, then it would log all the errors thoroughly and exit in that crucial failure state. Clear signal again.
Got it. And what did they call this nifty tool they built?
They called it BuildByScript. The notes admit it wasn't the most creative name.
Functional, though.
Very functional. It perfectly described its single focused purpose: to build a database by running a sequence of scripts defined by a folder structure and a list file.
And what inputs did BuildByScript need to do its job? Must have been pretty straightforward.
Just 3 things: the name of the database to be created, the location, like a server name, where it should create it, and the path to the root scripts folder that contained all the subfolders and that crucial folder list file. Simple, focused.
Okay, this is the critical connection then. Now, instead of manually building those baseline and new databases for the commercial Delta script generator, they could just point BuildByScript at their version-controlled script repository. Step 2, automated.
Correct. The source databases for the Delta generator could now be reliably built on demand directly from the definitive version-controlled script definitions Much cleaner.
So they can now automatically create the Delta scripts and automatically build the databases needed to generate them. Brilliant. But the huge remaining piece is getting those updates, along with maybe other potential files, reliably deployed and executed on hundreds of remote sites, often by non-technical staff. That must be the focus of the next layer.
Absolutely. That next challenge was automating that last mile, getting the generated Delta straw and potentially other necessary files out to the sites and orchestrating the actual database upgrades there.
And did they build something completely new for this, or did they leverage what they already had?
They leveraged BuildByScript again, actually, but in a slightly different role.
Oh, how so?
Well, since each site had multiple databases needing upgrades, right, they used BuildByScript as a sort of focused execution engine or maybe a packager. They'd create a BuildByScript package containing the specific scripts needed for each separate database that needed upgrading at a particular site.
Interesting. So BuildByScript wasn't just for building databases from scratch anymore. It was also used to run a specific set of upgrade scripts on an existing database.
Exactly. Its core function, running a list of scripts and reporting success or failure, was repurposed. And to orchestrate the running of these multiple BuildByScript packages at each site, they built a new application.
Okay, what was this one called?
The Generic Implementer, or GI for short.
The Generic Implementer. This sounds like the crucial piece running on the site to manage the actual upgrade process. What were its core functions? What did it do?
The GI had several critical responsibilities, all designed specifically for robust remote execution by potentially non-technical users. First, it would figure out exactly which BuildByScript packages needed to be run for this particular update.
So it knew the list of tasks for this specific site update.
Right. And here's a really key design point for safety. Before attempting to run any BuildByScript package for a database, the GI would first create a backup of that database.
Essential, the safety net. If anything goes wrong, you can always revert.
Precisely. Then, it would run the first BuildByScript package for the first database, and its logic was strict. It would only proceed to the next database's package if the current one completed successfully, giving that clear success signal from BuildByScript.
Step-by-step dependent execution. Makes sense.
Yes. And if a BuildByScript package failed, gave that failure signal, the GI would immediately restore the database from the backup it took just moments before.
Preventing a partially completed, potentially corrupting update from remaining. That's a really robust design, especially for distributed systems where things can go wrong.
Absolutely. And the final piece, which the notes say was truly groundbreaking for the support staff.
Yeah.
If any package failed during the process, the GI would automatically email the central support desk with copies of the error logs.
Wow, that shifts the dynamic entirely. Support knows about a failure before the site even calls them.
That was a massive change. The notes highlight this as groundbreaking. It freed up the non-IT site staff immensely. They basically just had to start the process and then it ran unattended. Support could be proactive, not reactive.
I can imagine. That must have drastically reduced support calls and those expensive site visits related to failed upgrades.
Huge impact.
I can see how that would be transformative for their operations, but automating something that was previously manual, requiring human oversight, did everyone just embrace it immediately?
Well, not immediately, according to the notes. Apparently, some IT staff saw the generic implementer as bit of a scary monster.
A scary monster? Why?
Because it was this black box that just did things automatically without showing you every single minute step it was taking inside. If you were used to manually running scripts and seeing every line execute, watching the messages scroll by, this probably felt like a loss of control, or visibility at least.
That's fascinating, the human side of adopting automation. Even when it's demonstrably better, faster, safer, that lack of familiar visibility can be really unsettling for people.
Yeah. They actually had to give presentations internally, explaining how the GI worked under the hood, just to help alleviate those concerns and build trust in the automated system.
They had this incredibly effective system now, automating Delta script creation, managing the source databases via BuildByScript, and reliably deploying updates to remote sites using the generic implementer, complete with built-in rollback and proactive error notification. Was this the final form of the system? Did they stop there?
As is so often the case, success introduced new possibilities and new complexities. The notes actually say, and that should have been the end of it, but it wasn't.
Of course not. Automation breeds new requirements, doesn't it?
Exactly. Because they could now roll out updates so reliably and relatively easily, they decided to start releasing smaller update packs between the major versions.
Ah, okay. So sites weren't just on, say, version 1 or version 2. They could now be on 1.1 or 1.2, maybe 1.3, and you could potentially have different sites all running different minor versions simultaneously across the network.
Precisely. And this created a brand new problem for the upgrade process. When a site went to install an update pack, the system now needed to figure out exactly which minor version the site was currently running,
Right.
and then apply the correct sequence of updates specifically for that version path to get it to the new target version.
The system needed version awareness right there at the site level. It couldn't just blindly run a generic upgrade pack anymore. It needed context.
Which led to the development of the final layer in their automation system, the universal installer.
The universal installer.
Okay.
Did they modify the generic implementer to add this version logic? Or build something new again?
No, and this was a really smart design choice, highlighted in the notes again. They kept the generic implementer focused on its core task. Run a package, handle backup restore, report success failure. Simple, reliable. The universal installer was built on top of it.
Like adding a coordination layer or an orchestration layer really feels like they were consistently building with these modular components.
That's exactly the right way to think about it. The universal installer's core function was basically intelligence. Determine the site's current database version, and then select and execute the appropriate generic implementer package, or even a sequence of GI packages needed to get that specific site version up to the target version.
So the universal installer was the brain, figuring out which GI tasks to run and in what order, depending entirely on the site's current state.
Yes, a single universal installer release package could actually contain multiple different generic implementer packages within it. The UI would then run whichever ones were needed, sequentially. And crucially, it retained all those safety features from the GI layer.
It still orchestrated the initial backup before anything started.
Yes, before starting any of the GI packages, and it still automatically emailed success or failure status back to the support team.
And failure handling.
If any individual generic implementer package within the sequence failed, the universal installer would stop the entire process right there, ensure the restore happened via the GI, and then alert both the site staff and the support team.
So they ended up with this really elegant layered system. You had BuildByScript at the bottom, creating or running focused sets of scripts. Then the generic implementer handling the reliable execution of those sets with backup and restore running on the site. And finally, the universal installer adding the intelligence layer on top to pick and sequence the right GI sets based on the site's current version.
Exactly. A fully automated process capable of handling not just the initial pain points, but also the new complexities that were introduced by their own success and growth. It managed the hundreds of sites, the multiple databases per site, and now the varying minor versions running concurrently across the whole estate.
That's genuinely impressive scale managed by an internally developed system, especially for that era.
And there was one final touch that really speaks to the value of visibility, tying back to those earlier concerns about the black box. The email feedback from sites, the success failure notifications from the UIGI, wasn't just read by humans. It was automatically collected and fed into another SQL database.
Closing the loop. Providing that high-level visibility, maybe for management or support dashboards, to address those concerns and track the real-time status of the entire distributed system.
Precisely. It gave them clear oversight into which sites were successfully on which major and minor versions. And just as a tech detail, the notes mention the underlying technology for all the internal tools they built. BuildByScript GI UI was PowerBasic, which is kind of an interesting choice for that era of development.
Bringing it all back to you, our listener, listening right now. Why is this story particularly relevant today, even though it happened years ago?
Well, I think it's just a fantastic blueprint for tackling complex, evolving problems. They didn't try to boil the ocean and build a single monolithic solution from day one. They used incremental, layered automation.
Yeah, they built simple, focused tools that did one job really well, like BuildByScript just running scripts, or the generic implementer executing a sequence reliably with rollback. And then they used those simple, robust tools as building blocks for a more intelligent, higher-level system, like the universal installer.
And this layered approach allowed them to adapt much more easily when new requirements, like those update packs and the versioning complexity, emerged unexpectedly. It also shows the power of building in reliability at each layer.
That binary success-failure signal, the automatic backup restore.
Exactly. Because that reliability is what enables automation at scale. Designing for clear signals and robust failure handling is just absolutely key.
It's a really powerful reminder that sometimes the most sophisticated solutions are actually built by combining very simple, very reliable components in clever ways.
A true testament to iterative problem solving and leveraging simple tools really effectively.
So maybe a final thought for you to take away. As you look at a complex process in your own work or life, maybe it's onboarding new clients, maybe deploying code, or even just managing a large, multifaceted project, ask yourself, could breaking it down into smaller, automatable steps be the key?
Could you build simple, focused tools or repeatable procedures for those individual steps, and then combine those building blocks to handle the overall complexity, maybe preparing you for future scale or those unexpected twists that always seem to come up?
And maybe think about how designing systems or workflows in distinct layers allows you to add functionality or adapt to change more easily over time without having to constantly dismantle and rebuild everything you've already built. Something to ponder.
Definitely something to ponder.
Well, this was a fascinating deep dive. Thanks for joining us.